Have you ever wondered how your radio gets both left and right audio channels from one FM signal? Let's talk about FM multiplexing.
FM broadcasting was a marvel of engineering when it was invented in 1933. Compared to AM radio stations, FM had a much clearer sound and was much better at rejecting RF interference. For a real-world example, try listening to an AM station during a thunderstorm. You'll hear a static crash every time lightning strikes nearby. This doesn't happen to FM broadcasts.
In 1961, the FCC in the US approved the use of stereo FM broadcasts. It involves using audio frequencies in the received FM signal above the range of human hearing that can be used to convey additional information.
This is a representation of what your radio gets out of the FM signal. You can see 4 distinct parts. Occupying the space between 30 Hz and 15 kHz is the sum channel. The sum channel is basically what it sounds like, the left and right audio channels added together. Its frequency range closely matches up with the range of human hearing between about 20 Hz and 20 kHz.
This sum channel is all that existed before FM stereo. It's still there today to remain compatible with radios that only have one speaker. The sum channel can be thought of as a type of AM signal. The loudness of a signal at a given frequency depends on its amplitude.
At 19 kHz, you can see another signal. This is called the stereo pilot. Radios that support stereo look for this. It's also protected out to 4 kHz on either side, which is why the sum channel is cut off at 15 kHz. The pilot is filtered out of the sound your radio makes, but it's unlikely you'd be able to hear it anyway. If you don't believe me, you've been listening to a 19 kHz tone for the past 10 seconds already.
If your radio can hear the stereo pilot, it knows there's something else out there. So it takes the 19 kHz tone and doubles its frequency. This is called the second harmonic. Centered on 38 kHz is the difference signal, left minus right, as opposed to left plus right in the sum signal. This is another type of AM signal called double sideband suppressed carrier, or DSB-SC.
A stereo receiver can do some algebraic operations on the two signals to extract both the left and right audio channels. They're added together to get the left channel, and the difference is subtracted from the sum to get the right channel. The formulas work out. RDS, or RBDS in North America, is centered on the third harmonic of the pilot tone at 57 kHz. This is the signal that contains the name of the artist and the song currently playing on the station, as well as a few other flags, such as whether the station airs a traffic report.
This is a subject that really appeals to radio nerds. I'll be putting an extended cut of this video on YouTube soon, so if you want to know more, be on the lookout for that. The link to my YouTube channel is in my TikTok bio. Until next time, follow for more.